digital. Okay, multiplexer. Multiplexer is a device which multiple input and only one output is there. Output is only one or multiple, and in order to select the particular there are given, it is on select line to input to output. Select line are n, so inputs will be 2 raised to power n and output is always 1. Because if select line are 2, so input lines will be 4 and output is always 1. If are 3, input lines will be 8 and output will be 1. So multiplexer is used. So just move to question. Question 6 below are the logical realized by the circuit below is. So we have out the logical multiplexer given. Now here the select line Q. This what? This to 1 marks are the input and 1 is the select line. So in order when Q is equal to 0, then it will select I0, and when Q is equals to 1, it will select I1. The logic will output for I1 plus Q for I0 plus Q I1. So here I0 is equal to what? It is grounded. Ground means digital. Ground means digital 0, and if we are applying some voltage, we see that is digital 1. Ground means digital 0. So I0 is 0 and I1 is given by T. Y will be equal to for I0, that will become 0 and that will be the output A is. Okay, to the next question. Next question says that again the type of multiplexer says that a multiplexer 2-bit multiplexer means that 2-bit select lines. Okay, select line multiplexer shows the output for output to be XOR of C and D, the value of A0. What they are asking, have to find out this value. XOR C D equals to what? C bar D plus how we can put XOR. I just write this output. The output Y is equals to is 0. In this case, select line S1 both should be 0 in order to select the input A0. Similarly, here not should be 1 in order to select A1 plus 1 in order to select A. Lastly, both should be 1 in order to select A3. How we will find out the output. Now they are saying that it should be the output. If I am writing instead of S not N1, if I am writing C and D, it should be. Now in this case you see we want this and this term only, and this we don't want. So we will put A0 equal to 0 and A3 equal to 0 and A1 equal to 1 and A2 equal to 1 in order to get the value, which will be CD bar plus C bar D. That is XOR operation. So in this case, we got the values A0 equal to 0 not equal to 0, C option will be correct. A not equal to 0, A1 1, A2 1 and A3 0. This is how we will be finding out this. Next question. In next question, the figure below shows that a multiple where S1 and the select line, I0 to I3 are the, and En is the enable. The enable line basically confirms that the mux is in operation mode. So if I have to keep the enable on, only in that case mux is on, or any other combinational circuit, demux or decoder, whatever. Okay, so when enable is on, then device is working. Enable is off, the device is not. Here enable is a low. When I will be putting it at a 0 line, a 0, if I give the enable 0, that case mux is that, check that multiplexer is on and it will giving the output. En is the enable, have to find R, F is the output. So now F output in terms of P R, I'm writing it again. How you write it? Now instead of S1, I'm writing P directly. Okay, in order to select first input, so that will select the I0 plus, writing it again, like expanding it again. So I'm writing in terms of inputs and S1 I0, how it will pick I0. So when this is 0 0, when select lines are 0 0, I0 will be collected. When select lines are 0 1, input I1, 1 0 input I2, 1 1 input I. This is how R I1 plus I3. Q, I0 is R at I0. For I1 it is 0, 0 plus per is equals to last case PQ1 will be per Q bar R plus bar R plus Q. So we have to simplify it further in order to get it the option. Simplify it further by using K-maps, best method. If you start solving, instead of doing that, just take K-map, solve it. PQR second from K-map. So it is P bar Q bar R. Bar Q bar R. So this one P bar R. So this, and this is, and where is for this and this. So this will become P is positive, so it's just P R plus one will be only, there will be per R. correct option. Q plus QR. Right, I have marked this, and marked this. Marking will be positive here, and Q is positive and positive. So 1 and 1 here. So this and this. Okay, 2 pairs, this case, and we got. Okay, moving on to next question. 4 variables realized 4 cross 1 marks as shown in the figure. You have to find out the minimized expression. Now there are like 2 muxes connected together, right? So we will be solving the first one and then the second one. Solving the first one first and second one. So solving the first one. I have told you when it is ground, it is logic 0, and when it is VCC voltage, the logic 1, right? So for first mux, if I am having select lines as UV, so it will be bar I naught plus U bar V I1 plus UV bar I2 plus UV I3. In this logic, we have the values of I0 is equals to 0 plus I1 is equals to 1 plus I2 is equals to 1 and I3 is. So what is this logic? This is U bar V bar. So this is nothing but U's or V, right? U's or V. We will take this expression as our output here. Y so we take this as Y equals to U's or V or Y. Okay, so this is your mux number 1. So mux number 2, I'm solving it here. Now for mux number 2, you can see what? Logic 0, I2 and I3 is logic 0, and I0 and I1 are provided by output of the first mux is equals to Y, which we have already calculated, which is equals to U's or V, right? Let's just solve for second one. So second one is X. Now in this case, I0 is equals to Y plus second case, I1 is equal to Y plus 0 plus 0, since I2 and I3 are 0. This solve it little here only. That is W bar Y is common. X bar plus X, it will become 1, right? So bar Y. So the value for Y is nothing but UV star. So U bar V plus UV bar. If I open it, you need to open it. The answer is given in this way only. W bar UV bar, right? Moving on to the next question. Question says that a programmable logic array, programmable, is shown in the figure below. Have to find out the Boolean expression f, which is the output of this. VLA is not did with a XOR and gate. And gate is not properly. If I put this dot this for this, so it is, so this cross means they both, all these terms are ANDed. So how does a PLA work? This should come under, but it's okay. They have given AND gate. PLA, you see cross you see, basically means they all are, they point are ANDed and given to the OR logic. So ANDed means we will multiply this. So F will be P bar for first AND gate, Q bar and R. Now moving on to the next AND gate. So it is P bar, Q and R. P bar, Q and R. Moving on to the next, it will be P, Q bar and R. P, Q bar and R. They all are ANDed. Give the final output. Will be option is okay. So the next question. Okay, marks represented this shape. It is like 1 marks. Again, the output of 1 marks is given to the another. Solving it. First marks. First mark. First mark select line is X. Your 2 inputs. So if I write it, X I naught, X I1. Okay, so I am, a Y is already an, this 1. F1 is X bar I naught is equals to Y is given, plus the other input is 0. It will be 0 only. 1 is X bar Y. Now this is given to marks. So for second marks, if I talk, so function f I am writing here, Z bar I1 plus Z bar I0 plus Z I1. Z bar, what is your I0? I0 is function f1 only, which is X bar Y, plus Z I1 is inverted f1, which is X bar Y whole bar. To solve it further, so that is X bar Y Z bar plus Z. If I open this, so that will be X bar bar plus Y bar. X bar bar will be X bar only. X bar bar will be X only. XZ plus Y bar Z. So this is your final output F. Option the correct option. Right? How you will be solving this? Take the first marks, the first input according to the syllabus. Okay? Take the intermediate output and don't expand it, because it will be making the things complicated. Just a one variable thing, and after solving the other marks, just put that one variable like we are doing it. Okay, moving into the next question. Next question says that, wait, lengthy question. So it says that, next question says that for the circuit shown figure, the delays, so delays are given. So the delay of NOR gate some 2 nanoseconds. The delay of multiplexer is 1.5 nanoseconds, and the delay of inverter, which is NOT gate, is 1 nanosecond. If the input are P, Q, R, S and T applied at the same time instant, the maximum propagation. So basically they are saying that for this mux, it is 1.5. For this gate, it is and for this it will be 1 nanosecond, right? The total amount of delay. Now in this case we can see that this T is applied to the select line. So select line is S0 here and S0, both the select are selected by this T, and at T is equals to 0, all the inputs are given. Okay, all the inputs are given. Firstly, this will work rapidly because others are connected the inputs, right? So it will take 2 nanosecond, it will take 1 nanosecond, but at T is equals to 0 only, it will get, and at T is equals to 1 nanosecond, it will start operating. So at T is equals to 0, it's saying that if I am saying if T is equals, there will be two cases. If T is equal to, and T time is this time, at a time T is equals to 0. At a time T is equals to 0, will be activated. So right. Now if we see that the value of S0, if T is equals to 0, value of S0 will be, and value of S0 mux 1, and for mux 2, for mux 1 will be equal to 0, and for mux 2 it will be equal to 1. So if it is equals to 0, it will be selecting which input, this input or this input? Yeah, it will be selecting the first input. So if I am saying the value of S0 is 0, that means this value will be select input number 1. So how the operation will flow? So it will start from NOR gate, then it will process the input from mux. Now in this case, which input is selected? This input is selected. Now mux output is going to this gate and to this. So this is not selected in the first case. So input 1 is selected. So input 1 is selected, that means the output will be directly going to this. So no time will be taken. So mux 1 and mux 2, and finally the output. So how much time will be taken? Here 2 plus mux 1, 1.5 plus mux 2, 1.5, that will be 5 nanoseconds. But this is our first case, right? We have another case. Another case, if I am saying T is equals to 1. So for T is equals to 1, T is equals to 1, so your second case, S0 value will be equal to 1 and S0 1 for mux 1, and for mux 2 it will be inverted. It was 1, it will become 0. So basically this input will be selected in this case and this input will be selected in this case. So how the flow will occur? Firstly, it will pass from the inverter, NOT gate, then mux 1, then now this is selected, so it will pass through OR gate, and then finally mux, right? This is the flow. Now we will add all the time. So it is 1 nanosecond plus 1.5 plus 2 plus 1.5. That will be total of nanoseconds. So out of 5 and 6 will be max propagation delay that will occur into this circuit, right? 6 nanoseconds, the maximum propagation delay. Understood? Right. Moving on to the next question. The next